In this video, I'll consider one numerical on initial and final value theorems. Verify initial and final value theorem for f of t is equal to e power minus t, t plus 1 whole square. Here the function f of t is given. We need to verify initial and final value theorem. We know that initial value theorem is given by, that is, initial value theorem is defined as limit t tends to 0 f of t is equal to limit s tends to infinity s f of s. Let me consider this as left hand side expression, this as right hand side expression. Now consider the left hand side expression, that is LHS is equal to limit t tends to 0. Here the function f of t is e power minus t, t plus 1 whole square, that is e power minus t, t plus 1 whole square is equal to, so here if you take t equal to 0, the value of this expression will be 1. So LHS, that is value of this expression, will be 1. Now we'll verify RHS part. So to verify RHS part, first we need to calculate f of s. F of s is Laplace transform of f of t. First let me calculate Laplace transform of f of t. So we know that Laplace transform of f of t is equal to f of s. So now in a given function, first let me consider only finding Laplace transform of t plus 1 whole square. So we know that t plus 1 whole square will be equal to t square plus 2t plus 1. So we know the formula, that is Laplace transform of t power n is equal to n factorial divided by s power n plus 1. So if I apply this to this equation, I can get Laplace transform of t square will be, that is 2 factorial divided by s power 3 plus, if I apply to this, I can get 2 into, that is t, that is here power is 1, that is 1 factorial divided by s power 2 plus Laplace transform of constant 1 will be 1 by s. So factorial of 2 is 2 itself, that is 2 by s cube plus here it will be 2 by s square plus 1 by s. So this is the Laplace transform of t plus 1 whole square. So now we know that Laplace transform of e power at f of t will be equal to f of s minus a. Now let's shifting theorem. So therefore, let me calculate Laplace transform of given function, that is Laplace transform of given function e power minus t, t plus 1 whole square is equal to, so here if we compare with this expression, we can see that value of a is equal to minus 1, a is equal to minus 1, and already we have found Laplace transform of t plus 1 whole square. So this is the Laplace transform of t plus 1 whole square. So here f of s minus a means each s should be replaced by s minus of minus 1, that is s plus 1. So in this equation, each s should be replaced by s plus 1. So let me write this, that is we have 2 divided by s plus 1 whole cube plus 2 divided by s plus 1 whole square, and we have plus 1 over s plus 1. So this is the Laplace transform of given function. Now let us verify RHS. that is RHS is equal to, here in initial value theorem RHS is S f of S. So S f of S will be equal to, now each this term is multiplied by S, so we'll get 2S divided by S plus 1 whole cube plus 2S divided by S plus 1 square plus S divided by S plus 1. Or I can rewrite this expression as, that is S f of S, that is RHS equal to, I can represent, so further I can represent it as 2S divided by S cube 1 plus 1 over S cube plus we have 2S divided by S square 1 plus 1 by S square plus S divided by S 1 plus 1 by S. This is same as the previous expression. Let me simplify. Here 1S and 1S will get cancelled. We'll get 2 divided by S square 1 plus 1 by S cube plus here 1S will get cancelled. 2 divided by S 1 plus 1 by S square plus here we have SS will get cancelled, 1 upon 1 plus 1 over S. So therefore now I can write S f of S tends to infinity, which will be equal to, here S tends to infinity means this term will be 0 plus this term will be 0 plus here S tends to infinity, 1 upon infinity is 0, so we'll get 1. So therefore S f of S tends to infinity is equal to 1. So therefore we can say that already LHS is equal to 1 and RHS is also equal to 1. Therefore LHS is equal to RHS. Therefore initial value theorem is proved. Now let me verify final value theorem, that is final value theorem. So it is given by limit t tends to infinity, f of t is equal to limit s tends to 0, s f of s. So therefore I can write limit t tends to infinity, the given function is e power minus t plus 1 whole square is equal to e power minus infinity, value is 0, so this entire term will be 0, which is nothing but LHS is equal to, so similarly RHS will be equal to limit s tends to 0, that is limit s tends to 0 s f of s, which is equal to, so already s f of s we have calculated, so this is s f of s. If we substitute s equal to 0, this term will be 0, this term will be 0 as well, this term will be 0. So therefore s f of s is equal to 0. Therefore we can say that LHS is equal to RHS. Therefore final value theorem is also proved. Thank you for watching.